As we continue on in our series of surge protection and application, technologies, installation, now we want to go into our test lab and look at the actual surge generator and compare two different types of surge tests, standardized tests, and various different topologies of technology for clamping transients and surges. So this video will be a little bit longer than the others, but we hope you enjoy it. And now let's go into our test lab. Okay, real briefly, wanted to give you some close-ups on our surge generator here that we have in our facilities. This generator is capable of producing the two standard IEEE ANSI C62 41 wave shapes. Let us zoom in on the screen here, and then you can see a few things that I'll point out. Here on the screen here, we have the selection between the combination wave, and as we would select that, we would load the standard user test here. You can see combination wave, line to neutral. We'd hit that, say OK, and here bleeding up the 6,000 volts, line to neutral. Exiting out of that, the other standard wave shapes are the ring wave, which is the 100 kilohertz. Here, 270 degrees, 2,000 volts, line to neutral. You're capable of changing the voltage to go up to the full 6,000 volts, 500 amps on the ring wave test. Again, this is a standard surge generator capable of creating the combination wave and the ring wave, for which we'll illustrate here of our various testing of different types of surge suppressors. Okay, what I want to do here is test a couple of different technologies, just to illustrate how they perform, how they function. As we showed the surge generator, we'll start off with the 100 kilohertz ring wave. And this is a typical, what we call a DIN rail mounted unit that is found as lightning or surge protection in many panels. And we've hidden the name so that we'll protect the innocent or the guilty. We will apply power to the unit. This one has no LED, so there's nothing to see. The generator will charge to 2,000 volts and release it, and then we'll illustrate its clamping on the screen itself. Okay, here with these red lines, we'll get down to the base of the sine wave. So we injected it at 270 degrees, and with the top cursor, we'll measure the top. And this unit here has a residual or let-through voltage of 900 volts. So with respect to protecting electronics, it's not really going to do a very decent job of removing or eliminating false zero crossings. Okay, let's take this unit off, and we will now test a panel-mounted type device. These are very popular. They'll provide typically maybe a little more lightning protection. This unit here is sold around the world. We'll zero out the scope, apply power, and charge the generator. Again, we're staying with the 100 kilohertz ring wave. The last one was 900 volts. This one does a little bit better job on the ring wave. We're at about 580 volts. So this is more of a hybrid type of unit rather, as opposed to just a straight metal oxide varistor. Okay, let's clear that. We'll remove this unit, set it aside. This unit here is quite popular. It can be mounted internally into a panel itself or externally. And this unit itself actually has an audible alarm that will signal when there's problems within the unit or when the dry relay contacts are not connected. So we're going to test this one line to ground as opposed to line to neutral. And we'll apply power. LED is on. charge up the generator. And this one is almost identical to the previous one. We're at about 580 volts. So very similar type of technology with respect to attempting to clamp the ring wave transients. Now this time let's test our ECS's technology. This is one of our sine tamer units we had available, which is sold internationally. Here in the USA, it's Surge Suppression Incorporated, as we've discussed. We'll also test this one line to neutral and demonstrate the technology that we've been discussing with respect to actually following or monitoring the sine wave itself. LED is on, so power is applied. As you can see, there's almost nothing on the sine wave, so we'll have to change the scope itself so that we can zoom in on that small little transient that's left over. Now here we have approximately 50 volts. So out of the best of the other types of technologies, we've taken another 530 volts, 520 volts away from the connected loads of this equipment. This is the type of technology that 21st century equipment in today's facilities demands to have in order to get the full benefits of that.